Shuffle is one of the most widely used features in basically any music player, allowing users to mix up their playlists and discover new songs. It's a great way to mix up your genres, find new favorites, and yeah. We all know what shuffle is. As humans, we're so spontaneous and want that feeling of not knowing what's coming next. Spotify is one of my favorite apps, and I use shuffle all the time. What I love is that it just always hits the right spot. Even on playlists that have electronic, hip hop, rock, it's just magical. How do these shuffle algorithms even work though? It's just random, right? Okay, but what is random? How does a computer think of random things? How do I even think of random things? Cars 2 on Blu-ray.
Well, do you want true random or pseudo-random?
There's a difference?
A true random number means that the computer needs something outside of the computer to measure, something away from itself, like maybe a timestamp of when you hit a certain key, or the speed of some frequencies.
And what is pseudo-random?
Basically what it sounds like. A computer has a predetermined algorithm of how it will generate this random number. If that algorithm is for some reason exposed, it could be pretty easy to guess what that next number is going to be.
So what's the purpose of something like real random?
If you wanted to get into encryption, you would want something real, or perhaps some extreme military-grade security to prevent any bad actors from doing anything suspicious. Imagine hackers, or quackers, understanding everything your computer does at random to exploit you and start cyber warfare.
Okay, what about like shuffling 50 songs?
Oh yeah, pseudo-random should be okay then.
Okay. Let's see how Spotify used to handle shuffling songs. It used something called the Fisher-Yates shuffling algorithm, which is common amongst lots of software. Let's say I had 5 songs in a playlist and I wanted to shuffle them. The index will determine which change of position it's going to be in. So when we generate a random number like 3, we switch positions 5 and 3. We then move the index to 4. We roll a random number between the first index and our current index and we get 2. So we switch songs 4 and 2. This continues until there's only 1 left. Boom, shuffled. This algorithm is very popular and is implemented in almost any programming language. It's also known for producing unbiased results if implemented correctly. We won't go there though. Okay, is the video over that quick? Like, comment, and subscribe for more. That's the issue. Spotify was very confused when they received backlash on their shuffling system. After investigation, it worked as expected. Users were saying that the same artist would play 2 or 3 times within a short period of time. So it turns out Spotify didn't have a bug. Our pesky little human brains have a bug that sadly can't be fixed. We actually just suck at estimating probabilities, and there's actually a term for this called the gambler's fallacy. Let's say we're at a roulette table and we're guessing what number the ball will land on. You have a 1 in 38 chance in landing on something. Well, 1 in 38 in the US, I think it's like 37 elsewhere. You see that it landed on 2 ones and then landed on 2 again the second time. This must mean that the probability of it landing on something higher is much higher, right? Well, this is wrong. Probability in those circumstances is not affected by context. You have the same probability of it landing on a 2 for a 3rd time than any other number. So for music, just because I listen to "You Might Think He Loves You for Your Money, but I Know What He Really Loves You For," it's your brand new leopard skin pillbox hat, doesn't mean I'm more likely to get Baby Shark right after. Martin Fiedler wrote an article called The Art of Shuffling Music, where he gives a great example about using random algorithms in music shuffling. Assume the above is shuffled, you have a random sequence of C's right through the middle, and B's not automatically shuffled fairly. The issue is that this is actually random. Our stupid little brains are silly, aren't they? But as they say, the customer is always right. So they decided to work on a new solution. Within Martin Fiedler's article is a solution he developed called the balanced shuffle. Spotify used this technique, but alternated to their own needs. This is how it worked. It first takes the pre-shuffled playlist and then groups them by artist. It then takes the length of the biggest groups and adds dummy tracks to the other groups. These dummy tracks are then placed at random. Then by analyzing the columns of this order, it goes column by column, retrieving all tracks from one column and removing the dummy tracks. The order from this column is randomized using an actual shuffle. The randomized track is then added to the final playlist, rinse, and repeat. A tweak added is that if it detects that the first track of the column it's on is the same as the group from the last column, it will instead be moved to the end of that current column. Martin then takes that list and splits them out in chunks to be seen as even more random. A similar technique can be seen in image processing called dithering. Dithering is when you add noise to a piece of media, usually in the form of reducing color significantly. In this image here, you can see that it's black and white, but realistically, it's just a whole lot of shades of gray. If you wanted to simplify this with actual black and actual white, you can use dithering so that depending on the percentage of gray something is, that is the chance of it becoming black. So following in the theme of random, you can see that the final result of this is actually a little hard to see. Another form of this exists called the Floyd-Steinberg dithering algorithm, which uses something called error dispersion to better distribute this. This does the same thing as before, but this takes the old pixel that it just scanned and then the new pixel it found and calculates what is called the error, which is the difference between the old and the new. It then spreads 7/16 of this number to the right, 3/16 in the bottom left, 5/16 below, and 1/16 to the bottom right. Why those numbers? Good question. These guys are smarter than me, so I'll just take their word for it. And the result is a much more distributed and easier to view image. When Spotify shuffles all the music, using Martin's method above, it then tries to find a way to somewhat evenly distribute these songs throughout the entire playlist. So if there was 4 songs by Daft Punk, it would need to appear roughly every 25% of the length of the playlist. For songs with only one artist, it uses a random offset to place randomly amongst the entire playlist. They then use the Fisher-Yates shuffle, which, now that I think about it, sounds like a pretty awesome dance, to shuffle the order of the songs amongst one artist in the playlist. Spotify says that this is only implemented in just a couple lines of code. Come on, Spotify. Let's see that source code. So as we see, mathematical computations are never technically incorrect. However, human beings with our stupid little pea brains need to optimize these mathematical algorithms to make them feel more random to us. Which brings me back to the original point of this video, real random versus pseudo-random. At first, even I thought that real random was the right way to go. I don't want any of that fake crap. However, as we understand the psychology of how we actually want and perceive random, having to trick ourselves is what makes us really enjoy it. So for us humans with stupid little brains to feel real randomness, we have to build algorithms to trick ourselves into believing what random truly is. In Spotify shuffling and in the Floyd-Steinberg algorithm for dithering, you can see how we have to manipulate math and science a little bit in order to better optimize what technically is mathematically correct for the better of our entertainment or attention spans. So the article that I'm basing this video on is on the Spotify engineering blog, but it was posted about 10 years ago, in 2014. What's funny is that this was actually an issue that Apple had back in 2005. Smart Shuffle allowed users to make it so that users wouldn't get artists back to back. I'm not sure what algorithm they used, but when Steve Jobs announced this, the audience giggled. Less random.
Next is Smart Shuffle. You know, we've gotten a lot of people that say our shuffle's not random. Well, it really is random. But sometimes random means you've got 2 songs from the same artist next to each other. It just happens randomly sometimes. And so what we've added is Smart Shuffle to actually make it less random, if you want. Even though people will think it's more random, it's actually less random. And what it is, in Preferences, there it is right there, it says, Smart Shuffle allows you to control how likely you are to hear multiple songs by the same artist or from the same album in a row.
Thanks for watching this video. This is my first video up in my new set. Let me know what you think about it. Also, if you want to see how more tech companies are building their products and solving these cool programming issues, I've created a playlist with all the rest of my videos, one including Discord and the other Instagram. I also have a newsletter called The Better Dev, which I share content like this, but in small snippet versions directly to your inbox. What company should I cover next? Peace out, coders.